A couple of weeks ago I did a video about code smells. If you haven't watched that yet, I'll put a link in the description. I really enjoyed making that video and I think you enjoyed it too, so I'm doing another one. The 7 smells that I'll cover today are just as bad as the smells from the previous video that I did. And I'll also give you a tip of what you can do to avoid code smells in general. Let's dive in. If you're new here, you want to become a better software developer, gain a deeper understanding of programming in general, start now by subscribing and hitting the bell so you don't miss anything. The example I'll be covering today is a vehicle registration system. Let's go through the code quickly to see what it looks like. There's an enum that represents the fuel type of a vehicle. We have an enum representing the status of the registration system. Then we have a set containing tax values for different types of fuel. There's a custom exception that we're going to use later on. Then we have a data class vehicle model info, which is a class that contains basic information about a particular vehicle model. So there are things like brand, model, catalog price, fuel type, year that it was launched, etc., etc. It is a property tax that computes the tax that should be paid over this vehicle if you buy it. So that depends on the fuel type and the catalog price. And then there is a method that returns a string representation of the model information. We have another data class called vehicle, which is the actual vehicle that has a reference to the information about the model of the vehicle. It has an ID and it has a license plate, and it also has a toString method that returns a string representation of a vehicle. Then we have a class vehicle registry that maintains a list of vehicle model info instances, so it knows the different models that are out there. It has an online status. There's a method for adding a new model to the registry that creates this vehicle model info instance for us. Then there are a few helper methods for generating vehicle IDs and vehicle license, so these use a combination of functions from the random and string packages. Then there's a method called register vehicle that, given a brand and a model, looks up the vehicle information, generates an ID and a license plate, and creates a vehicle instance for us. The final method in the registry is online status, and that reports whether the registry is currently online. And finally, we have a main part where we create an instance of the registry. We add a couple of different vehicle models to it. We verify that it's online, register a new vehicle, and then print out the vehicle information. So let's run this code and see what it does. As you can see, it prints out a registry status and then it registers a vehicle with an ID and a license plate. So recap, what is a code smell? It's not a bug, it's more an indication that something's wrong with your program. It can be a minor thing, that's a really quick fix, but it can also point to deeper issues in your software design. Today, I'm going to cover 7 code smells. They're not all Python specific though, but they're still pretty smelly. The first code smell that we're going to look into is related to this add vehicle model info method here. And the smell is that this has way too many parameters. And there's 2 reasons for that. One, it's basically copying over all the parameters from vehicle model info. This actually is also related to another code smell called feature envy, which means that an object or a method needs to know too many implementation details of another object, suggesting that maybe they should be merged or split differently. And the second issue is that vehicle model info here doesn't have any default values. So let's solve this by doing 2 things. The first thing we'll do is add a couple of sensible default values to vehicle model info. And the second thing we'll do is change add vehicle model info to accept a vehicle model info instance instead of all these separate parameters. So inside vehicle model info, let's add a default value for fuel type and launch year. And we're going to need the date time import here. And then the second thing we'll do is simplify this function to accept a vehicle model info instance. There we go, that's much shorter. And then the only thing we need to do here is create these vehicle model info instances. And since we have default values now, we can, in many cases, remove all these extra parameters here. So let's run this code and make sure that this still works, and it does. Second code smell is using too deep nesting. Let's take a look at this register vehicle method here. You see, it's responsible for too many different things. It's responsible for looking up the vehicle information. It's responsible for generating all these IDs and then returning the vehicle. And the second problem is that the way it's set up is not very clean because it uses these nested if statements inside a for loop. And the problem with deeply nested code such as this is that you have a lot of empty space here, which makes it harder to read. And it's better to split these things out to make it a bit more simple and cleaner. So what we're going to do is separate these two responsibilities of finding vehicle info and creating the vehicle into two methods. So just going to copy this over and let's create a method find model info. And that takes a brand and a model, and that's going to return a vehicle model info instance. And I'll just delete this. And what we'll have this method do is that it returns an optional value. So let's use the optional type here. I'm going to import that. There we go. So when it finds the model, it's going to return the vehicle info instance, and otherwise we're going to return none. And now what we can do in register vehicle is to simply call this method to find the model. So that gives us the vehicle model, and if the vehicle model is valid, then we're going to create the vehicle ID and license and return the vehicle, and otherwise we're going to return this missing error. Oh, and that actually needs to be that. So even though we split out register vehicle into two methods, there's still a lot to improve here. The find model info method still has a lot of nested code. And the main issue is that we have these two nested if statements that we can actually combine by using logical operation, like so. And that already saves us one level of indentation in this method. Another thing I often like to do is to handle the special cases in the beginning of a method. If you look at register vehicle, you see that this is actually the main thing that the method is supposed to do. Generate an ID, generate a license, and create a vehicle for us. But there's a lot of code that's surrounding it, and this part is actually nested. What I generally try to do is that the main part of a method should not be nested at all. And the way to do it here is by basically turning around this condition. So instead of checking whether vehicle model is valid and then doing this inside the if statement, which basically introduces an extra nesting layer, we can also switch it around and say if not vehicle model, and then we're going to raise this vehicle info missing error. There we go. And now I can remove this and I can put this at a higher level of indentation. And now you see that we're looking for the vehicle model. We're handling the special case, which is that we didn't find the model. In that case, we raise an error. But then the main thing that the method is supposed to do is not nested at all. And this helps increase the readability of your code by adhering to this. In find model info, you can also switch the condition around, even though here it doesn't make that much of a difference, because this is actually the main thing that the method is supposed to do, find the vehicle info. And what you can do to swap this around is basically changing this if condition into its logical opposite. And then if we didn't find it, then we're going to do continue. And now the return vehicle info statement is indented one less level deep. In register vehicle, there's one more thing you can do to make it even a bit shorter, and that's by using the walrus operator. The walrus operator looks like this. So it's colon equals. The difference between the regular assignment and using the walrus operator is that the walrus operator returns the result of the assignment. So that means you can combine assignment and checking whether that succeeded in a single statement. So what you can do is then move this over to the if statement. And the only thing we need to do is add some parentheses surrounding the operator for this to work correctly. So now we've removed one more line of code from our register vehicle method. Personally, I don't use the walrus operator that often because I find it kind of obfuscates what a method is creating in terms of resources. Here it's not clear anymore that this is actually creating a new vehicle model variable. And if you put it at the top level, then it's clear that this is what's happening. The third code smell is not using the right data structure for things. Let's look at this vehicle models list. The problem is that finding vehicle model information is kind of cumbersome, because if you look at the find model info method, we have to go through each of these vehicle info instances, check that the brand and the model is the same, and if they are, then we return the vehicle. And we might do this quite a lot in registry. So the data structure that we chose to store the vehicle models, a list, is perhaps not the best solution for this. It might be better to have a kind of dictionary with keys so that we can find these vehicle model info objects much more easily. So let's turn vehicle models here into a dictionary instead. I'm going to use the dict type. What we're going to use as a key, because we're always looking for a combination of brand and model, is a tuple of two strings, the model and the brand. So let's also provide that as typing information. And tuple is something we need to import from the typing library. There we go. Let's go back here again. So now vehicle model is a dictionary. Of course, we need to initialize it with the empty dictionary. And now adding vehicle models, of course, changes slightly. So that becomes this. So the key is a tuple of the brand and the model. And there we store the model info object. So this I can remove now. So let's add vehicle model. And finding the model is now much simpler. And I see I didn't update the docstring. Let's also fix that right now. And let's use the get function that default returns none if the vehicle can't be found. And we're going to provide a tuple consisting of the brand and the model. And now this we don't need anymore. Let's verify this still works. Yes, it still works. Code smell number 4. Let's take a look at this online status method. The problem is that this uses conditional expressions, which is fine, that can be pretty useful, but we're using a nested version of this because we're returning offline if it's not online, else, and then this thing here is again another conditional expression. Don't do this because this is really hard to read. It's not really clear under what conditions which statuses are being returned. So it's better if you use these conditional expressions and it becomes more complicated to split them. So let's use the regular if statement to do this. And then the else part, we can actually return this. And now this is a bit easier to understand. Personally, I don't use these conditional if expressions that often. I mainly use it when you have a choice between two things and it's really simple and that fits on one line. I mean, then it can be pretty clean. But in all other cases, I mainly use regular if statements. The online status method in this example doesn't do that much. I mean, it doesn't check for connections and stuff like that. You would probably add that if it was a more complete example, but I kept it really simple here. Code smell number 5 is using wildcard imports. You can see here, I'm importing everything from random and from string. Now, generally, this is a bad idea because it kind of pollutes your namespace in the module because we have all the functions that are in random and all the functions that are in string. And this becomes confusing relatively quickly. For example, here, if you look where they're being used, that's in generate vehicle ID and generate vehicle license. You see that there's a choices function, there's ASCII uppercase, digits. It's not really clear where these are coming from. In general, I would advise against using wildcard imports and just import the specific things that you need. In this case, what we can do is replace these two imports by this. There we go. And now we should, of course, fix a few things here because it doesn't know what these things are anymore. Well, choices comes from random. This comes from string. So let's update these names here. Now it's clear where these variables and functions are coming from. There we go. I think we got everything. Let's try this again. Yeah, that still works. When you want to import a module, as a rule of thumb, use import module over from module import XYZ, unless you have a really good reason to do so. A good reason could be that a module is so common, like data classes or enums or datetime, that you can use from data classes import data class, because it's also probably used all over the place in your module. If a module name is too long, you can shorten it. Import pandas as PD or import numpy as np. Those module names are not even that long, actually. Anyway, back to coding, Arjan. Code smell number 6 is using asymmetrical code. Asymmetrical code means that you're doing the same thing in different ways. If you look at vehicle model info, it has a method to turn it into a string. Vehicle also has a method to turn it into a string, and they're both named differently. There's no reason to do that. In fact, it's even better to use built-in dunder methods like str or wrapper for this. So how to solve this? Well, simple. Let's just replace it with the str dunder method in both cases. And then we also don't need the docstring here anymore. And because vehicle model info now has this dunder method, then actually here this also becomes way more simple, because we can just simply print the info here. And the str method is going to take care of that conversion automatically for us. So then I can just remove this and I reduce this to a single line of code. So we have two quite similar dunder methods that return a string, str and wrapper. So when do you use which one? What I suggest is that you use str to produce a human readable string and wrapper to produce a string that represents the object. So the string produced by wrapper you could eventually use to recreate that object. In other words, str is more for the users and wrapper is more for the developers. Now it's time for code smell number 7, and after that I have a small bonus one for you. Number 7 is using self in methods that don't need it. Take a look again at vehicle registry. It has methods for generating a vehicle ID, generating a vehicle license, that both have self, but it's actually not needed. It's not used anywhere. So because it's not using self, it doesn't make any sense to pass it as a parameter, and you should probably just turn them into static methods. So let's remove self here, and let's turn these into static methods. One thing that you see is that this generate vehicle license method has a pretty long line of code. So perhaps it's a good idea to split this out to make it look a bit cleaner. So let's split this out into a digit part. And that's basically this. And we have a letter part, which is this. There we go, that's much better. To fix this smell, I used static methods. Python also has class methods. These are not the same thing. Class method is a method that has access to the class instance, so it can change class variables, class attributes. A static method can't do that. It simply belongs to a class just because that makes sense. In this case, you could even argue that generating a vehicle ID and generating a license shouldn't even be part of the registry, but should just be put in a separate module that provides helper functions to do this. Now, one more bonus smell, and that's related to the main part here. At the moment, this doesn't use a main function. It simply puts everything inside this if statement. That's a problem because every variable that you create here is going to be available on the module level, and that might lead to all kind of name clashes and shadowing and stuff like that. The solution to that is to always use a separate main function. So let's change this to actually use a main function. There we go. So it's good that you know about these smells as a software developer, but if you want to avoid them in general, know that there are tools to help you. I use VS Code as my main code editor, but they also have several extensions that I use, such as Pylint, Pylance and Black. Pylint is my linting tool of choice. Pylance adds a lot of extra features to VS Code, such as syntax highlighting, automatic imports and more. And finally, Black is a really good auto formatter, a really opinionated auto formatter, which I actually like. So the combination of these three things already helps me weed out a lot of the issues in my code. Another thing you can do to avoid those code smells that point to deeper design flaws is to really try and understand your problem before you start coding. And I wrote a guide to help you with this. It's available at ArjanCodes.com/design guide. It's totally free. It contains a set of bullet points, my steps that I go through when I design a new software application or a new feature. And I think you'll find it quite helpful in structuring your thoughts. So get it for free at ArjanCodes.com/design guide. So that's it for today. I hope you enjoyed this video. Thanks for watching. Take care and see you next time.